Okay, recording. Hello everyone. Hello Abdu, Abimombla, Abimo. Okay, let me call you Michael. Dimiso, Emmanuel, Mititi, Eni Ibong, Joel, Minitalla, Motasm, Bachman, Rokia, Sabah, Sar Mbang, Sufyan, Chidi, Yusuf, and Abdu. We have two Abdu, nice. Sorry if I butcher your name. So today we have this two LeetCode course schedule and implement Trie. This one we did it in the Trie PLD, but it's okay, we can do it again. And this week we're gonna see this LeetCode. If someone wanna jump on some of this LeetCode and host them, the one that are not green, you can do it. Yeah, let me know. And let's go. Let's start with the first LeetCode, which is course schedule. So let's try to understand it. Okay, let's read it. So course schedule, there are total of num courses you have to take label from 0 to num courses minus 1. You are given an array prerequisites. Let's read this. How do you
prerequisites?
Prerequisite. You are given array of prerequisite where prerequisite I equal A and B indicates that you must take course B first if you want to take course A. For example, the pair 01 indicates that to take course 0 you have to first take course 1. Return true if you can finish all courses, otherwise return false. Okay, let's see this example. A number of courses is 2. Prerequisite is we have 1 requisite which is for the course 1. We have to take course 0 before we can take 1. Output it true. There are a total of 2 courses to take. To take course 1 you should have finished course 0, so it's possible. Okay, and example 2 is we have also two courses and and for prerequisite we have 1001. So for to take the course 1 we need to take course 0, and to take course 0 we need to take course 1, so false. There are a total of 2 courses to take. To take course 1 you should have finished course 0, and to take course 0 you should also finish course 1, so it is impossible. Okay, let's try understand it more in like Excalibur. Who did not understand the problem yet? It's a bit confusing, right? But I hope it will make sense now. So this what they say. Let's take this too. Okay, so there are total of num course you have to take, label from 0 to 1. Okay, so from 0 to 1, from 0 to num courses minus 1. In this case we have 2 courses, num courses, so from 0 and 2 courses minus 1, which is 2 minus 1, which is 1. So we have like 2 courses. This starts from there. Courses. You are given a prerequisite where prerequisite A and B. So prerequisite, okay, here is it. Prerequisite indicates that you must take course B first if you want to take course A. Okay, so this one that we have prerequisite, right? We have 1 0, so we have 1 0. So to take course 1, I have must to take course 0. To take course 0 itself, I don't have prerequisites, right? So I assume it doesn't have any prerequisites. That's why it's not here. So anyone can come and take the course 0, there's no problem. But when you wanna come to take course 1, you have to finish the course 0. Now, okay, that's what you're saying here. So if it is possible to finish this 2 course, right, we're gonna return true. If it's not possible, we're gonna return false. But what is the case it's not possible? Like this one have this it's gonna bother me, this word. I'm gonna just say pre-request. Okay, let's say pre-request. So this one have pre-request 1 0 and 0 1, right? Which make it impossible to finish this course, because like, okay, I'm gonna go take course 0. Okay, what I need to do? Does it have any pre-request? Yes. It's saying to take course 0, you need to take course 1. Okay, let me take course 1 first. I'm gonna go take course 1. Does it have any pre-request before I take course 1? It's saying yeah. So to take course 1, you need to take course 0. So it's like a cycle, right? Like, okay, so I can start this because I need to start this, and to start this, I need to start this. So we should return false because we can't finish all courses. So this is the problem. Is anyone have any question about, like, did you understand it before?
What if in the second list we have maybe 2 and 3? It's it should return true, maybe.
Let me write it so we can follow. So in second list, which is this one,
yeah, we
have what?
Two and 3, or maybe
2 3.
3. Yeah.
Okay, so in this case we're gonna ask same question. Can I take course 0? Does it have any pre-request? No, it doesn't, so I can't take it. So okay, this is done. Can I take the course 1? Does it have any pre-request? Let me see. Yes, it have. What is it? To finish 0. Did I finish 0? Yes, so this one is also done. So yes, I can finish all courses.
Yes, okay.
Okay, who did not understand yet or have some question before we start brainstorming what will be solution for this?
If I understand, in the second example we are stuck in an infinite loop or something like that. Yeah.
Okay. We can't take any course because they depend on each other.
We'll always go back to the first course and do checking.
Okay, if there is no question. Okay, you want to say something? Someone said something? Okay, what will be the possible solution for this? We can just brainstorm, then we can see which is like efficient way to do it. Okay, let's bring this example with us. So we have this example which return true, and we have this example which return false. Okay, so let me suggest graph. It works this problem like it is a graph problem. So for example, we have two courses, right? Two courses. We have course 0 and we have course 1. And to take the course 0, I can take it. It have now no like connection with any course. But to take the course 1, I need to take first course 0. So this is the first case, right? Now if we do the same for the second case, which is to take, okay, we have also two courses, 1 and 0, and to take the course 0 we need to take course 1, and to take course 1 we need to take course 0. So maybe if we detect the cycle, we can say okay, this is not possible, false. If we didn't detect if there is no cycle, then we can say true, it's possible, right? So the cycle is the problem here. What do you think, guys?
Yes, this is what is the problem.
Any
Like infinite loop.
idea? Any idea? Think with me.
Hey guys.
Maybe we can have, I'm sorry, maybe we can have a visited list, and each time we visit a course we add it, and then once we visit that course again or the prerequisites are in the visited, then we just break the loop and return false.
Yeah,
Okay.
I think that's a cool idea.
Or someone else suggest something? Or was gonna talk to?
Yeah, I think what was suggested is kind of in line with my idea, the same idea. So
Okay,
I think we have a list.
Mhm.
We have a list. So I think we have a list of length 2. So we first of all check the second value, and then whenever we check if so we check the second value, and after that we put it in the list, and then we check the second one, and then we put it in the list. So once we are moving on from there, we check if we have visited what we have to. So we always check from the second position. We always check from index 1, and then compare it to what is there. So and then keep track of the count. So I think if we do it like that, at the end of the day, we'll know how long. They will compare it now to the number of courses.
Okay.
So,
Okay, you wanna guide me through that? Let's see how it will work. So, for example, okay, can you guide me through it?
okay, I think we can have a list.
Okay, let's say this is our list visited, right?
Yeah, that's the list. Yeah, we have our list.
And then what do we do? Like, do we start from course 0 maybe?
Yes, we can start on this. We have to go through our prerequisites. So we have to look through the prerequisites.
Requisites. Okay, let me write it here. Let's analyze this case where it have cycle. Then we see the case that doesn't have cycle. So the request is gonna be 1 0 and 0 1. So we're gonna loop. So we're gonna go to. How we're gonna loop?
We can
So I
either
think yes.
loop or even use recursion. That could work.
Yeah, we can do recursion. Maybe we create like a graph. We create this graph and then we launch recursion 0, and then 0 gonna go to like launch on its neighbor or pre-requested using visited. Maybe so we can use visited as a state of the course. Let's say 0 is not visited, and let's say maybe -1, or let's say 1 is visit or like ongoing visiting, and the third one maybe done visit. This maybe can be 1, this can be -1 or lead to 2 maybe. So we have 2 courses, right? So it's gonna, this array gonna be have 2 index for the course 0, index for course 1. So if we start maybe diff is here, the 1 gonna be at the first time it's gonna be ongoing visiting, right? 1. Then it's gonna go to all pre-requested, and if this one stop or like return true, for example, this gonna become 2. So we know that there's no like cycle here. In this case where there's cycle, if we launch DFS or like we launch DFS on course 0, it's gonna go 0 gonna be by the way, this should be here, but yeah. So let's say the case where is 0, we launch DFS on 0, it's gonna go check also its pre-request, but before it check, it's also gonna change this to 1, like it's saying, okay, we're checking the course 0. So def is gonna go check the course 1, and then if there is the pre-request, let's say pre-request did go check for course 2, 3, or wherever, or it doesn't have pre-request, it's gonna return this something to 1, and from it's gonna return here. But in this case we have a cycle. So what that mean? That mean when we're gonna go check 1 also is gonna go call for pre-request 0 because it's have it here. And when we're gonna go to pre-request 0, we're gonna check if visited of with this cone. Oh, 0 is gonna be 1, right? So this one is here because we launched DFS first on 0, it still didn't come back, it's waiting. Then this DFS launched on 1, so this also changed the state to 1. And when it go to 0, we found out that it have the value 1. That mean it is ongoing visited, which mean there is a cycle. This is one of way can be done using DFS. We can detect cycle like this. Okay, let me try to explain it more slowly because I think I did some mistake. So think of these 2 courses as graph, right? and they have this cycle, but we can't see it. This is just because we understand this, we can see it with our eye, but in the code we can't see it. So if we launch a defis, when I say we launch defis, let's say we're gonna launch how to explain defis. It's like a recursion function that will be launched in same time, and each return is depending on the return of the same function that we launch in middle of it. So let's say we launch defis on 0, and for 0 itself it's gonna go launch defis on the pre-requested. So 0 have pre-request 1, it's gonna go launch defis on them. It's gonna launch on 1, and this should return something to 0. Let's say it returned true, which mean like we finish course 1. But in this case, when we launch 1, we update the state. The state visited become like 1, and when it's gonna launch defis on the pre-request 1, which is this, it's also gonna change the 1 to state 1, and the 1 it's gonna also launch another defis on 0, right? Because when you launch this defis, it's also always gonna launch another defis on its pre-request. And when we check here, we're gonna have a check on the status. If we saw that status is 1, we can understand that there is a loop. That means some defis didn't finish. Now let's do a case where there's no loop. Let's see how it's gonna work. So if there's no loop, like this one, or let's just do it here. So there's no loop, which means this case doesn't exist. What's gonna happen? We're gonna launch defis on 0, right? Where is it? 0. We launch defis. Nothing. It's returned true, right? Because it doesn't have any pre-request. So we launch defis on 0. It's returned true. Now we loop again to the second course, right? Because we're gonna launch defis on all the courses we have. We launch it on 1. Okay, here is 1. Now here we have pre-request, so in the middle of returning, it's gonna launch another defis on 0, and it's gonna wait for it to return something to give us true or false. Now when launch it on by the way, this when we launch it on 0, v it's become 1, right? Ongoing visiting 1, v of course 0 1. When it's finished, v become 2, right? Done visit, so this is gonna become 2. Now when we launch it on the course 1, 1 also become 1, because ongoing visiting we choose the flag 1. And because it have the course 1 have pre-request 0, so it's gonna spawn another defis that will also check for the course 0. The course 0, this defis did check, does 0 have visited 1? If it have 1, we can understand there's a loop. If it doesn't have 1, we can keep going. We can check also for like 2. If it have 2, then we understand that we have done visiting. We can return true to this, and then this can return true. As long as there is no 1 we can just return true, which means there is no cycle. How I can try to explain it more? Let's see, who did not understand? Because I did not a good job in explaining. Me your chat. What if the same course is more than one course? Alright, maybe save the reverse request. I don't think that will cause problem, right? If the course is requested in more than one course, for example, let's say we have 0. Let's say here we have another course 2. That is also depend on 1. Another course 3 that depend on 2 and depend on 0. Yeah, there is no cycle, right? Any course I start, I'm gonna end up on the end. If I start 3, I need to do 2. So if I need to do 2, I need to do 1. So I'm gonna do 1, then I'm gonna do 2, and then I'm gonna do 3. There's no loop. If I wanna do 3, I need then to do 0. I will do 0 because it have no request, right? And then I can do 3. So this is have like OR. I do 0 and I need to do also do 2. Then I will do 1 and then do 2, then 3. So 1, which automatically will make me need to do 0, right? So 0. So I need to do 0, 1, 2, then I will be able to do 3. Right? Think? Let's check it. So to do 3, I need to do 2. To do 2, I need to do 1. And to do 1, I need to do 0. So okay, can I do 0? Yes, I can. Because it doesn't have any prerequisite. If to do this one, I need to do 1, then we have a loop here. I'll be stuck. Can you give me example, please? Okay, I guess that's what I did. 1, 0. This just. Okay, is this clear? This part?
So just to confirm, the visited only holds the number of the course, right?
The number inside like 0, 1, 2?
Yes.
No, this flag. We can like make A, B, C. So I will put A when I am not visiting, so the first time default value. And when I'm gonna start the DFS, when the function gonna start reaching this course 0, I'm gonna switch it to B. Because if another function come back to the same course and find out that there is B, that means someone before me visit this and he didn't finish. So there is 2 defs in the same time accessing this 0. Because if def is finish, it should be C. When the def is close, it's gonna make it C. But this is one of idea. I'm sure there's many. If you have some idea, you can try it. Okay, who have any other idea? Not, we can go with this. DFS. We can even try do another one on BFS. Okay, so how we can do this one? First, who did not understand, please open mic and talk with us or write in chat. Okay, let me remove this. Let's try to write a pseudocode for this and try to see if the algorithm gonna work or not. So first, what are we gonna do? So we said we're gonna have visited. Now what they give us in the code is just number of courses and pre-requests. That's all. So we can generate a graph from these two courses. So when they give us two courses, we understand. Let's create a graph. It's gonna be something like this. Then inside, so two courses, it means we have two courses, 0 and 1. So we say index 0 and index 1, and inside it we put the require course for it. So it's gonna be what, 0 here, 1 for 0, it's gonna be 1. So this is index 0, which mean course is 0 and its pre-request is 1. If it have more than 1, it can be like 3, 2. So this is array inside array matrix. So course 0, course 1, course 1, it have pre-request 0. So in this way we have a cycle. Okay. Now we have a graph. This is our graph. We need our pre-request, which is gonna be 1 0 0 1 pre-request, and this is graph, and visited, right? So visited also gonna be 2. So we know the number of courses is 2, so we can generate an array of 2 elements and we give it 0. Let's give it A to make it simple. A. We put a string A, which means it's not visited, right? It's just a flag. Okay, so this is visited. Now, how def is gonna work? First, where we're gonna launch def is on the graph or on the per request? Do we need per request or we can use just the graph? Okay, we can launch the course on, or like def is directly on this 0. Okay, let's say we launch defs. Okay, let's create defs first. Defs function. So what will be the base case? We have two base case. One, if it was B, we okay. So what we should return? Return true if you finish all courses, otherwise return false. So our defs can return true and false. So if I launch defs on the course 1, okay, maybe we do this one simple, then we do the one with the cycle. Okay, let me remove this. And this graph gonna be empty because it doesn't depend on anything. So we're gonna launch defs on the course 0. Okay, 0. and we're gonna check if it have visited. Let me remove this. If it have visited, check if visited, or like if visited equal a, return false. Which mean while I'm checking this course 0, another DFS was also checking 0, so two DFS accessing the same course, which means there is a cycle. And if visited equal wait, not A, sorry, B, equal ongoing visiting, right? So at first it is A by default, not visited. Ongoing visited gonna be B, and C done visiting. So if it was C, then return true. Which mean done. Which mean so C is like done visiting. That mean some DFS did check this course, did check it, and it like, let's say, so if someone, I try to find some example. Let's say there is two people, right? And you are asking someone, hey, did you check the course 0? And he say, yes, I finished it. If he say I finished it, he mean that he's finished all its prerequest, and then he put 2 on it, or like C. So if someone finish a course, that means he's not stuck in the loop, right? So if I did go to check any of this course, and I was like going to this visited, think about this like a friend, right? And you ask him like, what is your status on the course 0? And he said A, which mean I never learned that course, or he gonna say B, which mean I'm currently checking that course, right? Which in our case it means there's a loop. In this example it doesn't work, but it's work here. If he said C, it means he did finish the course. If he finished it, that means there's no cycle. In our case, if visited equals C, it means we're gonna return true, which means this def is gonna return true, and we're gonna loop to the next course. So before this def is like def is, let's call it, we're gonna give it course. So some way here we should do like loop on each courses and do defis course, and this can return true or false. It's gonna return true, which mean it's done visiting. So I can do like a return true, the return of this. But what if it's return false? No, I can't do, because we loop on each courses, right? Because what if there is too many courses? The first course return true, and the second course return true, but third course return false, which means there's a cycle there. So I need somehow to wait on all defs to finish. Maybe so if the loop gonna keep going on all courses. So we wanna break the loop if it is false. So if okay, let's save it result. Let's save defs in a result, right? If result is false, then return false. There is no need to check the next course, right? Because defs give us false. Now this is the pseudocode, but of course we need to this B and E and C, they need to change here, right? So defs need to change them. So this is the base case. Now if it is not B and if it is not C, it means it is A. It's not visited, right? So if the first time I'm gonna visit this, first thing I wanna do is change visited of that course to A, right? And what else? Launch another defs on all HTTP requests. Launch defs on all HTTP requests. Okay, and if everything return, change visited to 2, or like C here. Visited to C. Okay, let's see if it's gonna work. Oops. Okay. So let's start. We have the function defs and our code starts from here. We're gonna loop on course 0. Here we go. First we have so first we have we create visited that have AA default value, which means the course is not visited, right? We launch loop on H courses. Okay, here is our courses. We loop on the first one 0. We launch defs on course 0, right? So course 0. So this defs, it launched this function right here. What it do? It go check for visited if it's equal B of this course, of course, right? So this is just see the code. So it's gonna check the course 0. Is it B? No, it's A. Okay, we're not gonna enter here. Check if it is C. No, it is A. Not gonna enter here. Okay, now visited of that course to A. So we need to change. Let me write it correctly. Change visited of this course to B. Mistake here. Change visited of that course to B, which means ongoing visiting, right? Because DFS right now is going through this course 0. And okay, here is it B. Launch DFS on all HTTP requests, and this one have nothing here, right? So it's have no pre-request or like. So what's gonna happen is we're gonna change to C, second one. So there's no pre-request, which means we can do this course no problem. We change it to C. What that mean? It means done visiting. done visiting what? Done visiting course 0. So course 0 is good. Now this gonna return what? Return true. So we need to add here return true. Return true. Okay, here is it. This gonna return true to result. We're gonna check if result equal false. If not, probably we can optimize this right here. We can optimize it later. If not, so it's gonna keep looping on the second course. Okay, second course is 1. We do the same. It's gonna launch def is on course 1. Course 1 we're gonna check again. Def is gonna start on 1. It's gonna check if B it not, if C it not, change visit of the course to B. Okay, error is to B, which means we are currently visiting the course 1. And then launch def is on all its pre-request. Okay, now this one have a pre-request. Okay, we're gonna launch another def is from here on course 0. Now 0 also gonna start another def is, which is gonna say if visited equal B. Let's see, 0 it equals C, it not. If visited is equal C. Okay, yes, it is C. What does it mean? Return true. So this gonna return true. So we need to use this, because if it returns false, we know there is a cycle. So here we can do if true. If true, just keep going, right? If this is true, doesn't matter. If return is false, return false. Like return false if def is return is false. Return false, which means we're not gonna change to visit, we're gonna break the def is, right? We're not gonna change visit to C, and we're not gonna return true if it is false. But if it was true, we're just gonna go and change visit to C and return true. In our case it's C, so if it is C it's gonna turn true, which means we're not gonna enter here. We're gonna change it to C. What is we're gonna change to C? The course 1, right? So course 1 gonna become C, and then we're gonna return true. This is gonna return true. Okay, and it's not false, so it's not going to return false, and that's it. If it finished the loop, we're gonna return true, which means we access all the courses. That's why they have all C, right? It's possible to access them all. Now let's create a loop, a cycle loop. Let's see what's gonna happen. Okay, cycle loop is gonna be something like coming from 0 to 1, which means this also depend on it. And this 0 1 0 also depend on 1, and course 0 depend on 1, and at start this gonna be A. We have 2 courses. Okay, let's see what's gonna happen. We said loop on each course. Okay, first course 0. Where is it? What else? Send 0 in defis and wait until this defis come back, then continue, right? So def is gonna start here. It's gonna check if visited equal B, it not. Equal A, is it equal C, it not. Change visited of that course to B. Okay, change it to B. Okay, let's change it to be visit course 0. Launch Deface on all 8 prerequests. Okay, what's prerequest of course 0? Is 1. Okay, so here we're gonna spawn another Deface that's gonna pause this program, right? It's gonna pause this function here until this Deface that we spawn gonna return something here. Now Deface that we spawn here is about course 1, so another Deface gonna start with 1 and it's gonna check if visited equal B of course 1, no it's equal A. If visited equals C, no it's equal A. Change visited of that course to B. Okay, here is it B. Launch Deface on all its prerequests. Okay, so what is the prerequest of 1? Right, is 0. Right, so what's gonna happen, this also gonna spawn another DFS. This time is for course 0. Okay, now this course 0, right, is gonna do the same. If visited of course 0 is B, yes. Oh, it is B. Why? Because the first Deface that we launch is still waiting for this Deface, and this Deface is launched this one. So there is like a chain of Deface waiting. Now this third Deface, he found out that visited of course 0 is B. What it's gonna do? It's gonna return false. To who? It's gonna return false to this, right? Which is the course 1, right? And why we launch course 1? Because it's prerequest of course 0. So this gonna return false. And what that mean? If we go back to the course 1, it's launched the Deface here. Now return false if the Deface return false, and this one here did return false to this, which means this also gonna return false to this of the course 0, and the course 0 also gonna return false to the result because it's the prerequest 1 did return false. So it's like a chain of returning false just because one of the course return false. And why that course return false? Because some another Deface accessed the course and found out it's equal B. And then if results equal false, return false, and that's it. That means there is a cycle. Who have any question? I did not do a good job on explaining this one because I don't know. It's for me. It's not easy to explain Deface, but hopefully, if someone have question, I can answer them or someone here can clear them.
I would have question, but I was not able to join because of the network. So I really don't want to.
Okay, maybe we ask who did understand it. Who did understand the concept? No one? Okay, if you understand it, react with understand it, not and I didn't understand. Okay, react in chat. Who did understand? If you understand it, check green. If you didn't understand, check star. Okay, there's TT. Okay, let me put another like quick recap about it and then we code it. So the idea is like this. So think we have course 0, we have course 1, and this 0 is going 1 and 1 going to 0. Yeah, maybe I should go to the code. Okay, so 0 is have prerequest 1 and 1 have prerequest 0, which means to do the course 0 you need to do 1, and to do course 1 you have to do course 0. Now imagine you start a deficit on this one. Let's not say deficit, let's say how I can say it to make it easy to understand. Let's say you have okay, maybe I find something later. Okay, let's say we launch deficit on this one, right? To 0. Okay, maybe let's say you wanna go study this course, right? Okay, here you go, you are going to study it, and they tell you, oh, to do this course you need to do 1, and then you did go to 1, right? And they tell you, oh, to do this course you need to do course 0, and then when you go to course 0 to check it and you find in the visited value is B, you understand that you did start this course and you didn't finish it yet. Then you understand there is a cycle. That's what Dave is doing. It's like we launch Dave on this course, and then it's gonna go and check all the prerequests, and if any of prerequests end up going back to the same course, we're gonna check if it's equal B. If it's equal B, we're gonna return false, which means all of this gonna return false. So this is the main point that's confusing, but maybe like Minatella said, if we write code gonna be simple. Okay, so let's write code. I guess some sub-concepts are just hard to explain. I'm just joking. That the real synthesis sometimes I'm just bad at explaining. Okay, so can finish. Okay, so let's try to do this. So first we create the graph, right? We said we create a graph which is a matrix. So let's create it, graph. Now we know the course numbers is 2, so we can like create an array, right? And use the for loop to create us all the matrix or the array inside. So we can do array for in range of num courses, which is 2. So this gonna create a graph that have array 0 1, right? So this is gonna loop to 2, which is 1. So first loop we're gonna create this inside it, and second loop we're gonna create this. Okay, here we have graph empty. Later we need to put inside this graph this number, right, of the prerequest. Now we have this. Now we can do that. We have prerequest, and prerequest is like this, have x and y inside each array. So we can do for x, let's call them so this one is course, so let's call it C, and the second number is prerequest, call it P. In pre and then we're gonna access the graph by the first number, and we're gonna put inside the number second number, right? So this is graph 0. which this one, and its pre-request is 1. So I'm gonna access using this and put 1 inside. So graph index what? C, right? The course, and I'm gonna push to it the, because it's list, right? I'm gonna append to it what's the value of 1, which is the pre-request. Append what? P. We forget something here. Visited, right? Visited, we say it's gonna be array, or we can generate array that have value A. I can do it like this. And of course 2. So we need 2 of this array. We do it A. So what this gonna do is it's gonna make visited that have A twice, which is because we have 2 courses, so default value is A. Okay, now we have graph and visited. Now we need to launch a defis on H1, right? So let's create, before maybe let's create this part, then we create defis. So it's gonna be for loop on each course, for we can loop on each graph, for we can access the, okay, so loop for course in graph, but the graph have array, so course graph, or how do we do that? So this course, it's gonna be array. Okay. But I wanna launch defis on the array. Okay, this part I'm confused a bit.
We can use the course of 0, isn't it?
Okay, that's good. Yeah, because num courses is 2, so we can like loop twice. So for course in range num, like this. Wait, isn't this okay? So this way we have 2, because for example this way we have number 0, which is the course, and then we can launch defis on it. We can do like result defis and we give it course. And then if results is more like equal false, is false, return false. If not, just continue and then return true. Okay, so course is just a number, 0 or 1 or 2, because we know we have 2. Because we know we have 2, we can generate this 4 that's gonna go first time 0 and second time gonna go 1, and then we're gonna send this 0 to this one defis, and then from that 0 we're gonna access the course or pre-request. So we can do defis and then the course. Now we're gonna check if visited equal B if visitors of that course. Now we know the course is the same index, right? So visited is array that's have index 0 and 1, course 0 and 1. So let's have A. So this course right here have value 0. So I can access the visited by course, right? I can access the value and check if it's equal B. So course 0, check if it's equal B. If it's equal B, return false. If visited course equal A, not C, return true. Right? What else? Then change visited of that course to B, which means visited course to B. And then we're gonna launch Prefix on all HTTP requests. Now we know HTTP request is array that we have in graph, so we can access the graph by course index and loop through this. So for each request in graph of that course. So course 0, on each request inside we're gonna launch Prefix. Again it's gonna be like a result Prefix. This one we're gonna launch it with a request. And if result is false, return false. Or we can do, but it can be, maybe someone can't understand it. So it's like we're gonna launch Prefix on this request. If it was return true, we continue. If it was false, we're gonna return false. We're gonna break here. If it's return true for all the courses, that means we finished them, right? We finished the course. So we need to change visited to C. Visited of course equal C. And if we change to C, just return true. Okay, so this is the code, I believe.
I think the C should be a string instead of C.
Yeah.
And the B in line 12.
Yeah. Okay, hopefully. So this one we can optimize it, right? We can do if not Prefix return false, but someone may not understand it. Oh, okay. Do we run? Who have any question? I'm sure this one of the boring this code we made, because it's confusing a bit and it have so many defs. Okay, who have question?
The B and C, were they being initialized?
Is what?
How are we accessing them?
How are we accessing this visited?
Yeah, I'm asking, was there initialization? How are we comparing visited? Okay. Yeah, I've seen.
Yeah, so when we launch DFS, and at first the course have state A, so it's not gonna stop here. This is the base case, so we're gonna change it to B. Okay, let's run it.
Yeah.
Where? Okay, let's check if there is more. It's not. Turn. Okay, submit. Okay, 29. Oh, let's submit again because I know Sabah told me. Okay, 69. Okay, I guess we're not gonna take on that. Okay, so here's the code. Who did not understand? Let's. Thank you. Who did not understand it? Maybe with the code it will make more sense.
Could you explain line 6? Line 6.
Okay.
Line 5.
Line 5. Okay, so line 6 now. So this is let me paste the code. Okay, so let's maybe take the code to Excalibur. Okay, so in our case we have 0, course 0 and course 1, right? So we create a graph, which means we create this array that have this and this, right, twice, and visited, we create another array, visited, and we put A, and then we go to this looping on the pre-request, which is course 0 dependent on 1 and 1 dependent on 0, right? And we say C, which means the course 0, and P, which means the pre-request. We go to graph index 0, which is the graph is this one, index 0 is this. We append P 1, right, which is P is this one, the pre-request of 0, 1, and then we loop again because there's second element. We go to course 1 in graph, which is this one, and we append 0, right? And then we have this DFS, this loop that's gonna loop on each of this course, right? It's gonna loop twice from 0 and 1, and it's gonna launch DFS with 0. It's gonna, this first time it's gonna launch with 0. What's gonna happen is it's gonna check visited, B is not, it's C is not, it's A, and then it's gonna change it to B. So this is gonna become B, and then we're gonna loop on the pre-request of graph course graph, which is this one. No, sorry, this one. Course, which is 0, which means the first one, and the value in pre is gonna be 1, right? So we're gonna launch DFS on 1. So this one also gonna launch another DFS with course 1, and now DFS 0 is waiting for return for this to continue the program. And DFS 1, it's gonna start from beginning. It's gonna check if the course 1 is B, let's see, it's not, it's A. Course is C, no it's not, it's A. So it's gonna go to visited to course 1, it's gonna make it B. Then it's gonna go to graph course 1, which is this one. This one. This is the graph, and it's gonna enter its prerequest each time. So if there is multiple prerequests, it's gonna keep looping, launching DFS. Now first prerequest is 0. Now DFS of 0, it's gonna launch it, which means this also gonna launch another DFS with 0, right? So DFS of 1 is waiting here, waiting for this to finish the DFS 1. And DFS of 0 that we just launched the second time is gonna go to check if visits equal B. And guess what? It's equal B. Why? Because there is a DFS that is waiting. Think about this function here is waiting for this to finish, and this is waiting for this to finish. For at this moment in real time, same time, this DFS is accessing the course 0, which means there is a loop. So this one because it's found B, it's gonna return false. So this gonna return false to this, false, and this gonna return false to this, right? Because we said in one, if it is result is false, return false. So it's gonna stop everything, return false. And guess what? This also gonna return false because they have the same condition. It's false, return false. And this gonna return false to this and false, and the program all gonna return false at the end here. Which means there is a cycle, right? This depends on this depends on this. If there is no cycle, we will never have a DFS that's gonna access some course and defend B. Because when we finish any DFS, we put C. Right? So if I start this course and I keep going through all prerequests of it, each course I finish, I put C. C, C, C. Right? So even if I come back to here, I'm gonna find C. So that is the idea. Okay, if it's a bit hard, if you have some question, feel free to ask. I will do my best to explain. If not, maybe just watch recording one more time or try to solve it. We'll make it more clear for you. Okay, who have any question? Before we jump to the second LeetCode. So second LeetCode is this one, implemented Trie. Okay, this one we already did it. Tree, but we can do it again. So a tree, or pronounced as trie, or prefix trie, is a trie data structure used to efficiently store and retrieve keys in a data set. Okay, give me like a minute. I will drink water and come back. So maybe you guys also take a minute to drink water. Right back. Okay, I'm back. Let's continue. Retrieve keys in a data set of a string. There are various applications of this data structures, such as autocomplete and spell checker. Implements the trie class. Trie initializes the trie object. Void insert string word. Insert the string word into the trie. Boolean search string word, return true if the string word is in the trie was inserted before, and false otherwise. Boolean starts with string prefix, return true if there is a previously insert string word that has the prefix and false otherwise. Okay, a bit confusing. So we're gonna implement insert, which gonna insert the string word into the trie, and boolean, which gonna search in this trie. Okay, Now we need to remember what is the try. Let's see if I find that document again. Try. Okay, here it is. A trie, also known as a prefix tree, is like a tree data structure that used to store collection of string. Trie are used for efficient retrieval of key in dataset of string. But though, how do you look? Trie. I think it's like a binary tree. Okay, now I remember. Okay, so it's like a binary tree, and we save each or linked list, and we save each character in a node, and we do a pointer that at the end that's okay, the word finish here. Okay, now I remember.
Using an example like when you do a search, doing a search on, then the suggestions come.
Like each character it's bring the next character. Now in the search we're gonna return true if string word isn't tree, and start with we're gonna return true if the previously insert string word that has the prefix, and false otherwise. Let's take this to Excalibur out and see the example they give us, and we try to understand. So input is try, insert, search. Okay, so this is the function we did call. This is the arguments that we call them with. Okay, and okay, so we call first try. We have no argument, and it's return null. Okay, we insert apple to the try. Okay, we insert apple, it return null, and then we search about apple, search apple, it return true, right? Because we just put it, and we search for up, and it return false. Okay, because we put apple, not up, and then we search with starts with up, it return true. And then try, insert up, we search up, it return true. Okay, visualize on Python tutor. Oh, this the okay. Okay, we probably should do this when there is a recursion problem, because it will help us to understand it more. Okay, let's go back to here and try understand this one. Okay, so who did understand what we're trying to do, or what is the problem, and who did not? Any question? Okay, so we're gonna implement this try, that we're gonna insert words, and we are able to search them. It's gonna return true or false, or we're gonna able to search a prefix. Any idea? Any question? Oh, silence today. You guys probably tired. Okay, how we can do this? Let's start with solution. Brainstorm solution. Any solution? Do you remember what solution we did before? We did create this node, right? We create this node, and then it's empty. And then when we insert, let's say we're gonna insert apple, we check apple, and we go to first character. We check if it exists in the node. So this node is gonna have like let's say it's gonna have children, and flag. Children gonna be array of character, or like sorry, array of node. Not array, hash map, dictionary. Okay, so each node have this data structure, and end is gonna be either false or true. If false, it means the end word is here. By default, it's false. Sorry, if true, it means the end word is here. So we're gonna add a if it doesn't exist on the root, which means the root children, which is like a hash table. If it doesn't exist, we're gonna add it to it. We're gonna add a as node. So imagine a here, and then we're gonna loop on second one. So we were here, now we're gonna go here, and we're gonna check if it have b in its children. If it doesn't have, we add it b. We're gonna loop against second one, b, and we can add L, we're gonna add E, and because E is the end of character, this right here, we're gonna put end flag to true, and to it's gonna be equal true, or let's say a star marker here. So this is gonna be our insert. Let's say we're gonna add what we're gonna add a b. Let's say we're gonna add abc, new word, abc. So we're gonna do check here if it exists. If it exists, we're gonna go to it. We're gonna check if it have in children b. It doesn't have, so we're gonna add b, and then we're gonna go to the second character that we're gonna add to b, so it's gonna have another character c, and because this says last ending of the word, it's gonna be this start. This starts here because this start's gonna help us. We're gonna search. For example, if I search here about the word up, if I didn't have these stars, it's gonna be true, because I'm gonna go to A, I find it, P, I find it, another P, I found it. Okay, there is up here. I'm gonna return true, which should be false, right? Because this is a prefix of the real word that end here with star, apple. We never insert up into this tree, because if we inserted P here, it's gonna have a star, which means up is a word in this tree. Okay, so this is the idea about it, or how to insert and how to search using this start. And for start with, we can just search, it doesn't matter, right? If we find, because if we want a A, P, P. It doesn't matter if it has stars or not, because we are looking for a prefix. So if it was a word, it's okay. If it was a prefix, it's okay. Because up is a prefix of up. The word up is a prefix of itself. Okay, who got the idea, or who did not understand it well? Okay, no question? No question? Got it? Okay, so how we can do this? Okay, if the idea is clear, we can maybe code it directly, because it's a bit, I believe, simple than the others. So let's see. Let's see. Okay, so we need to create this node, right? This node that's gonna have children and end. So let's create it here with just a class. Class node. And let's give it its parameter. So we said it's gonna have children. So self. And it's gonna have end, which is a flag, by default is false. So this is not that we're gonna keep creating and adding to its character. Okay, so first class try, we're gonna we need this root, right? We need to create this root. So let's call it self root, and then we're gonna call the node that we create here. Now we have this root is empty, to have nothing, and now we're gonna insert. If they give us a word apple, we said we're gonna do what? We're gonna go for each character in the word, right? Apple. What we're gonna do? We're gonna check if this A exists in the root, right? Because if it exists, I don't need to create it again. I can just check maybe its children. So I need to create like a pointer, right? So the first pointer gonna be here. So let's call pointer. I'm gonna be pointing on what? On the root, right? Self, that's root. There is. And then when I'm checking for each character, I'm gonna check like if this character exists in children of the root. If character okay, so if it doesn't exist, I need to create, right? So if let's say if it's not exist, if character not in pointer children. So if the character is not in this pointer children, we gonna create it. Okay.
Yeah, I think on that loop, we're going to put on that loop there.
What? Can you repeat?
I think we need to loop into the roots, like the next through our nodes. I don't know if you get what I'm trying to say.
We have the root here in this pointer. Let's call it current.
Okay.
So if the character is not in this current children, we're gonna create it, right? So we're gonna do current children, which is this current children, which is like a hash table, right? We're gonna add it to the hash table. What we're gonna add? We're gonna add character, and we're gonna make it as a node, a new node, right? Which is the empty node here. Now that we did create a new node, it makes sense if we move this to the new node, right? The pointer, right? We should move it to the new node. So current gonna become what? Current children character, which is just created if it doesn't exist. But what if it exists? If it exists, it's gonna move directly to it, which mean it's like because what is the goal? The goal is to create apple. Let's say up is already exists and L and E doesn't exist. So the pointer gonna be okay. Okay, is A exist? Yes. Is B exist? Yes. Is B exist? Yes. Is L exist? Oh, it doesn't exist. Okay, let me create it. Is L have A? It doesn't. Okay, let me create it. And after we create them, at some point the loop gonna finish, right? Which means it will create all the character. Then the last character, it's gonna be in current, right? Then we can do current and true, which mean this is gonna become true, which means the word ending. Okay, so we check the root. Current is root. Check if each character of apple exists. If it doesn't exist, you're gonna create it and add it. Yeah, so in this case we're gonna have A and then P, and this P is a node that have children. This is node that have children in the end. P. So basically it's the root is gonna have A which is a node have children, right? And this children is also let me design it. So first root have A, and A have children and end. So children and end. This one false, and children is another hash map. And this hash map have what? Have A. No, it have P. In this case, it's gonna have P and B, right? P and B. And this P have children and ending. And this children is also a hash map, which have P. And this have hash map, which have L. So it's like it's going. It's like a chain of hash map. Okay, is the answer clear? Like who did not understand it? Okay, we can go to search. Search now. I guess it's gonna be the same, right? It just, if it not exists, we're gonna return false instead of creating node. So I'm gonna search for A. I found it. Let's say there is no.
Sorry.
Yes.
For the inside, if
Yes.
the character exists.
If the character exists. Can you repeat the question? I didn't hear you.
Yeah. I was asking if the character exists, what do we do?
Okay, so think about this pointer right here as the current.
Yeah.
And say we wanna insert up, but our loop is just have up. So we're gonna insert apple, but we have just up here. So let's see this code what's gonna create. So set current on the root. Here is it. It is on the root. And for character in the word, so first word is A. If A is not in the current children, creates a node, but it like exists here, right? So if the root, the current children have A. So this root, this is current children of the root, and P is current children of A, and P is children of B. So our current is pointing on self root, right? And this character not in the current children, we're gonna create it. But if it doesn't, if it already exists, we're gonna just move the pointer. We're gonna move this to here. Current children character, which is A. And then we're gonna loop. Is P exist in the children of A? Yes, it exists. So we're gonna loop to it. Is P exist? Is this P exist in the current, or like in the current node children? Yes, it exists. And the last element we're gonna ask same question: is L exist in these children? It doesn't exist, right? So we're gonna enter this current children node, and because we enter it, we're gonna create a new node in children of P, right?
Yes.
And it's gonna be L. Here, character L. So in the hash table that is inside P children, we're gonna put L. And then we're gonna move the current to the current children, which mean we're gonna move it here. And we're gonna ask, does it have E? No. Then we're gonna create. And because loop gonna stop, because E is the last character, we're gonna do current and true, which mean gonna do star here, which mean the flag end gonna become true, which mean the word did end. I hope that made it clear.
Yeah.
Now yes, please go ahead.
I think there's going to be a bug somewhere where we have this Apple app.
Yes.
What if, for example, initially it was app that was there, and then we wanted to insert Apple? I remember that we had made our current.end for our P to be equals to true. So I did not see anywhere where we changed it to false back. I don't know if you get what I'm trying to say.
Okay, wait. So you're saying the tree have already apple word or apple?
No, it's app, only app.
Okay, let's do it.
I don't think
Okay, here is it.
Up is the complete word.
And the bug gonna happen in which function? Insert or search or start?
Yeah, the last one, the app.
This one starts
Going
with?
to be in app.
Which function have bug? Which function? Insert or search or start with?
Insert. I'm talking about insert when we're inserting.
Insert. Okay, so we're gonna insert what word? What word we're gonna insert that it's gonna create a bug?
Okay, let's say we are trying to insert apple.
Okay, so apple. There's it.
All right. So when we insert apple,
Okay.
we'll insert. So we check that we can see A, and we can see P, and we can see P. So we now insert our L and our E, right? and then we'll mark our E as the end. That is, we change the current.end to be true. But remember that we had changed the current.end for our P before to be equals to true.
Let's just go step by step. So now we have this word upper, right? So
Yes.
if our answer doesn't have any bug, it means at the end we're gonna have something like this: L, E, and it should have star, right?
Yes, but remember our P has star now.
I will go just step by step. So if this is happen, it means there's no bug in answers. It's working fine, right?
Yes.
Okay, so now tell me, what is the case where it have the bug?
If you look at the diagram you drew, you will notice that we have asterisks in our P and in our E.
Yes.
So it means that both of them are having true. But P is supposed to change to false.
When you say true, what does mean? You mean the end flag of P?
Yes,
but
in our
how
P.
is that gonna affect the answer?
Okay, it is, well, I think when we try to search for it, we'll never be able to search for...
Okay, so now you're talking about search, not answer. Right? Okay, so...
Yes, but...
Okay, so... Yeah, I know what you mean, but I think I was confused. Okay, continue now.
So what I'm trying to say is, like, if we do not create the inserts properly, it is going to affect our search method. Because now we are having in our insert, we did not change our P, the end flag in our P to false. I don't know if you noticed it.
So it is supposed to be changed to change it to false?
Yes, so that when we are searching for Apple, I don't know, but I think we need to change it to false since every other ones are already false.
Okay, so
app should also be
that's what I think.
I think app should still be a complete word in itself, because if you're searching for app, only app, and it already exists in the application, if we remove the if we end the false, if we change the end to false, then our application will never have app, but it already existed before.
Yeah, what you're saying is true, because let's say insert apple and then insert up, right? And I'm searching, I said, okay, search for up, and this wasn't here. I'm not gonna find it, right? But if it was here, I'm gonna find it, I'm gonna return true. And if I search for apple, I also am gonna find it.
Yeah.
Did you get it? Did you get why this is important to be here? So wherever we insert a word, we have to add true at the end of it, so we know that we insert it. You know what I mean?
Yeah, I get you.
Yeah. But let's see. Maybe you're right. Maybe there is a bug. I guess we are in search now. We're gonna find out.
Yes.
So in search, if they give us apple, again we're gonna loop on each character. We're gonna see the first character exists there. Then we're gonna move the pointer to the second one. If it exists, right? If it doesn't exist, what we're gonna do is we're gonna return false. Doesn't exist. If it exists, we're gonna move the pointer to the second character, and we move the current pointer to second node. Exist. Okay, move to the next one. Exist. Move to the last one. Exist. And now, because I'm in the last character, I can check if it has star. Because if it doesn't have star, it means this is probably Apple S, not Apple, right? Maybe someone answered Apple S, just example, right? and I'm looking for apple, not apple s. Yeah, apple s exists, but it's a prefix of apple s. So I need to check when I reach the last character of this prefix. So let's start it, how we can do it. So we're gonna do the same, probably the same code. Let's copy it, call it here, and so we set the root pointer on the root. We loop on each character. If the character not in the current children, we're gonna return false. Return false, right? If I come to the root and I check for first character A, I didn't find it. This means there is no word apple here. So return false. If I find it, then I move the current children to the next one, right? So I will move this here from the root to the next character, and yeah, so move this right here. Let's remove this. Move this here and loop again, which means it's gonna go to the second character. Okay, if you didn't find it, it's gonna return true. At some point, it's gonna keep looping until it's gonna reach the last one, right? Which is this E. This E. Now, if it reaches the last one, what do we do? Which is this last one, it means it's finished the loop, right? Then I'm gonna check if current and equal true, right? True. If it is, return true. Else return false, or we can just return this, right? Return current end. Does it make sense? Right, because if and the last character have true, I can return true, which means I found it. I have any question? And that's how we're gonna search. We need to check for this, the last start. What do you think? What about start with the prefix? Prefix actually doesn't matter if it's part of the word or it's a word. As long we find all this character, I'm gonna return true. If I didn't find anything, I'm gonna return false. So basically it's same code again, but I'm not gonna return this. Let's see what we should return. So I'm looking for up, right? Let's say up, it doesn't have star, so we answer it's only up. Current self root, and we're gonna check the root. We found A inside, okay? We're gonna loop to the second node. We're gonna go to P, check P if it's inside, right? If it's not inside, we're gonna return false. As long as it's inside, we're gonna keep moving current. We're gonna move it to P, and we're gonna check if it have P inside, and then we're gonna move current to P. We actually doesn't matter this part, as long we find, if we find the loop, if we find the last character inside P, then we just return true, right? We find all the character. If we find all of them, then return true. Is it confusing for someone? Is it clear? Okay, let me put a vote in the chat. It is clear, react with check mark. Not clear, react with star. Okay, I see too many clear. Okay, if too many clear, who did not clear it? I can repeat it, not a problem. If you have question or something, don't be shy.
You have to
Not be
modify
shy.
the for char in words. You start with function.
This one.
For chat in prefix, I think that's what you wanted to do.
Oh yeah, alright. So in prefix. Good eyes. Okay, let's run it. Okay, accept it and submit. Let's see. Okay, nice. Okay, that's it. Nice. I hope you guys enjoy this boring LeetCode. It's okay. Hopefully the next LeetCode is not boring. And also, if you did not understand well the course schedule one, maybe watch recording again, because the DFS is confusing a bit. Okay, so see you next time. If you guys don't have any question, next episode gonna be the queen change and products of array except self tomorrow. Okay, who have any question before we go sleep? Yes, you can say.
No questions.
Mititi, you wanna say something?
No.
Okay, see you next time tomorrow, inshallah. Have a good night.
Thank you. Have a good night.
Good night.